So before we get into the vector notation, and we should first talk about what a vector is. And a vector is basically something that has direction and magnitude. By direction, it's obviously in which direction the arrow is pointing, and by magnitude, it's basically like how how big the arrow is, or like how much position changes, or how great of a value the position changes at. And when looking at a vector, there are two main points. Its initial point, so which is like where you start, where your first destination is, and your terminal point, which is where your end point is. So for this case, the initial point is basically San Diego, California, and the terminal point is Olympia, Washington. Now, there are also two components to a vector, which are its vertical component and horizontal component. And the horizontal component would be a change in position on the x-axis, as you can see, and a vertical component is the change in position on the y-axis. Now, when looking at vector notation, you can see that it looks similar to a fraction, one number on top of the other, and the top number is the horizontal component and the bottom number is the vertical component. Now, there are two ways to write vector notation, but I think this is the one that's more commonly used. And so as you can see, when looking at these 2 points and the vector notation, if you basically add these points together, you would get -2 or 6. Or if you just add one of these vectors to the other, you would receive the others. It would be equivalent to one of the points. So, for example, let's add this to point A. -2 plus -6 would equal -8, and 6 plus -2 equals +4. And over here, we can see the actual movement of the point. So it would be, so the horizontal component would be -2, so we go back 2, and it would be the vertical component would be +6, so 2, 4, 6, and you would end up here. And that's pretty much actually what a vector is. So let's go on to the next destination. So from B to C, our vector would be 6 to -2. And if we add that to B, 6 plus -8 is -2, and -2 plus 4 is 2. So, and over here on the graph, you can see we go 2, 4, 6, and then we go down -2, or down 2. And that's how, that's the vector from point B to point C. And just to make it clear, the initial point would be Olympia, Washington, and the terminal point would be Cheyenne, Wyoming. Because although this was our terminal point previously in this one, since this is now the new starting point, this becomes the initial point, and this is the new end point, so that's the terminal point. So we go from C to D. The vector would be 5 to 2, so it would be over 5 and up to, or if we add it to C, 5 plus -2 is +3, and 2 plus +2 is +4. So we would go 2, 4, 5, and then we would go up to, which is right there. And the terminal point is D, and the initial point would be C. Now let's go to the next one. So this is from St. Paul to Albany, New York. And this vector would be 8 to -2. And adding that to point D's coordinates, that would be 8 plus 3 is positive 11, and negative 2 plus 4 would just be positive 2. So as you can see, if we go here, so we go 2, 4, 6, 8, and then we go down 2, you would end up right there. From here to here. And this vector is from point E to point F, negative 3 to negative 7. So we would go back 3, or yeah, so we go 2 and then we 3, because you'll end up with 8, and then we go down 7, so that'd be 2, 4, 6, 7, and you would end up at point F. If we add that to point E's coordinates, that would be 11 plus negative 3 equals positive 8, and negative 7 plus 2 equals negative 5. Okay, and like I mentioned before, as you can see, these vectors are now starting to form a shape. And with vectors, now we're going to be going into adding vectors, because if we add all these vectors, it would give us this missing vector without us even having to create one on GeoGebra. So if we were to add all these, you would basically add all the horizontal components plus all the vertical components, and the sums of both would be this vector. So 8 plus negative 3 is positive 5. Positive 5 plus negative 2 is positive 3. Positive 3 plus 6 is positive 9. And positive 9 plus 5 is 14. So just remember that our horizontal component sum is 14. And for the vertical component, it would be negative 2 plus negative 7 is negative 9. Negative 9 plus 6 is negative 3. Negative 3 plus negative 2 is is negative 5, and negative 5 plus 2 is negative 3. So, this vector should then be 14 to negative 3, based on our addition. And to check if it's right, we can do what we've been doing before. And yep, see the vector here is negative 14 to 3. And if we were to add that to this point, we would get the coordinates of point A. So negative 14 plus 8 would equal negative 6, and 3 plus negative 5 would equal negative 2. And as you can see, it forms a general shape. So, yep, that's it. That's all there is to vectors.
Hi everyone, today we'll be talking about vectors using the map of Greece. We'll be using vectors as a route for our starting point to our final point. So our problem is, first we'll look up a map of a country, which is Greece, then superimpose an XY grid over the top of an image. 3. Find a city in the lower left-hand side of the grid, quadrant 3. As starting point, make sure the city lies exactly on an intersection of lines. And finally, number 4, explain using vectors how you would go from the starting destination to the final destination. The endpoint of each vector should try to land on a city, or as close as possible, along the way to your final destination. It should have at least 4 vectors before you reach your final destination. For our procedure, we will use vectors into finding a way to get to our destination, which is from Argostoli in the 3rd quadrant to Athens in the 4th quadrant. For review, the upper right-hand corner is the 1st quadrant, the left upper corner is the 2nd quadrant, the left lower side is the 3rd quadrant, and the lower right corner is the 4th quadrant. So, our steps into solving the problem. Our first step is to determine our givens. So the first given is our starting point, which is Argostoli in the 3rd quadrant. Our ending point is Athens in the 4th quadrant. Each vector must end on a city and must have at least 4 vectors before reaching the final destination. Our second step is to set the relationship between givens and the problem. Because the problem is dealing with vectors, let's review what a vector is. A vector is similar to an array. They both look the same, but is measured by magnitude, length of a vector, and direction, way of a vector. The starting point of a vector is called the initial point, being indicated by a point or a dot, and the ending point is called the terminal point, being indicated by an arrow head. There are 3 ways to notate a vector: by the given notation, which is vector AB, or by counting the spaces between the 2 points. For example, point A is -4, -2, and point B is 4 and 2. Spaces between them is 6 up and 6 to the right. To notate them, we would add chevron 6, 6, or simply add parentheses and put both numbers on the top and on the bottom. Our third step is solving the problem. So our first vector would be to Argostoli to Arta. Our second vector would be Arta to Lamia. Our third vector is Lamia to Sparta. And our fourth vector is Sparta to Athens. Vector 1 has its point A is -3, -1. Point B is -2, 3. Our vector 2 is -2, -3, and 2 and 2. Vector 3 is point C, 2 and 2. Point D is 2 and -4. Vector 4 is point D, 2 and -4. And point E, 5 and -1. These are the points that make up the vectors. So the definition of the spaces of the vectors mean how much space does from one point have to go to another point. Such as the first vector, you have to go 1 space to the right and go 4 spaces up to reach the other point. So the second vector goes 4 to the right and 1 down. The third vector goes 0 to the right or left and 6 down. And the fourth vector goes to 3 spaces to the right and 3 spaces up. So to determine the total amount of all the vectors, we can create new vectors by adding the current ones, such as AC equals AB plus BC, giving us AC equals 5, 3. AD equals AC plus CD, giving us AD equals 5, -3. And finally, CE equals 3, 9. By adding the total of the new vectors, we can determine the total amount of all the vectors. So by adding all the vectors that we found, we got 13, 9. In conclusion to the video, the total amount of all vectors from starting point to the final point is 13, 9. Thank you for watching.